Hello dear students, last lecture we have seen the Laplace transform of some important functions, that is unit step function, exponential function, sine function and cosine function. Today we are going to see the Laplace transform of hyperbolic sine and cosine function. So ft is equal to sine h omega 0 t. H is for hyperbolic sine function. So ft is equal to sine h omega 0 t. Again, we are going to use Euler's identity here, same as the Laplace transform of sine function. So Laplace transform of sine h omega 0 t is equal to 1 upon 2 e raised to omega 0 t minus e raised to minus omega 0 t is equal to 1 upon 2 L e raised to omega 0 t minus L e raised to minus omega 0 t is equal to 1 upon 2 1 upon s minus omega 0 minus 1 upon s plus omega 0. So Laplace transform of sine h omega 0 t is equal to omega 0 upon s square minus omega 0 square. If we compare this hyperbolic function with sine function, we here the formula for Laplace transform of sine omega 0 t is omega 0 upon s square plus omega 0 square, but in hyperbolic function we get omega 0 upon s square minus omega 0 square. So this is the difference in the formula. Then let us see the Laplace transform of hyperbolic cosine function. So Laplace transform of hyperbolic cosine function is equal to 1 upon 2 e raised to j omega 0 t plus e raised to minus j omega 0 t is equal to 1 upon 2 Laplace transform of individual terms, that is Laplace transform of e raised to j omega 0 t plus Laplace transform of e raised to minus j omega 0 t is equal to 1 upon 2 1 minus s omega 0 plus 1 upon s plus omega 0. So if you solve these brackets, we will get s upon s square minus omega 0 square. So here this same difference is there in hyperbolic sine Laplace transform. At numerator we have omega 0, and in cos hyperbolic function Laplace transform we have s at the numerator, and denominator is s square minus omega 0 here also, and s square minus omega 0 here also. So denominator of both sine function cosine function are same, and denominator of hyperbolic sine function and hyperbolic cosine function is same. So let us see sine function. Laplace transform of sine function is omega 0 upon s square plus omega 0, and cosine function is s upon s square plus omega 0. But in hyperbolic function, the Laplace transform of sine h omega 0 t is equal to omega 0 upon s square minus omega 0 square, and Laplace transform of cos h omega 0 t is equal to s upon s square minus omega 0 square. So this is about the Laplace transform of hyperbolic function. Thanks for listening.